We envision a future where the waterways are a critical part of our transportation infrastructure, where small, efficient, zero-emission fleets are shuttling goods and passengers at a cost and scale that has never been possible before.
We're building an autonomous electric hydrofoiling craft that cuts the cost of operating small vessels down to about 1/10 of what it previously was. Waterborne transportation was once really a key integral part of our transportation system, and we've seen it over time be displaced by the automobile. Now we see that today reversing in a sense because our highway system now is stretched beyond capacity, and it's really time for a change. What coastal cities have in common is the waterways. This is a free piece of infrastructure that's just sitting there underutilized.
If small water taxis can be made low cost, their popularity will explode.
Technology-wise, I think we're really at an interesting point. Firstly, with autonomy, we can really get that labor cost down to a point where it makes sense to operate these craft for a small number of passengers. And same in the fuel bucket. By using electric power and hydrofoiling technology, we can get that fuel cost down also. Over the past 5 months, we've been working on building out the core pieces of our autonomy technology. And today, we're at a point where we have demonstrated really the key pieces of an end-to-end autonomous vessel.
We outfitted the test boat with a number of sensors, whether that radar, cameras, and integrated the autonomy system. We test this boat in various parts of the estuaries, in the bay.
We've really worked to build algorithms and build an approach that works for a congested harbor situation. So limited maneuvering space, crowded with other vessels, because that's going to be critical for this future where you have autonomous shuttles coming in and out of busy harbors. The way the technology works is we start by getting data from various sensors: radar, camera, GPS, AIS, engine monitor, etc. We take that data and we combine it together to create a digital representation of the vessel itself, as well as the area surrounding it and other vessels and obstructions. That digital representation is then used to create a safe plan through the environment that also complies with navigational rules or call regs. The route is continually updated using the latest information from the sensors multiple times a second. And finally, the system then issues commands to not only the steerage system, but also the engines to execute the plan. I grew up in the Pacific Northwest. I've been driving boats since I was 7 or 8 years old, and so just a ton of time on the ocean. Part of the unique piece I bring to this project is really understanding, what does it mean to operate a boat? What does it mean to be out there on the water? And then taking that firsthand knowledge and translating into what does the computer need to think about? How does it consider this environment? And how do we make sure that it is handling all cases? Because the ocean can be a very unforgiving and challenging place at times.
In order to actually develop a really good autonomy system, you need to collect a lot of data. We partnered with one of the largest US ferry company that allows us to get data feeds from 40 of their boats.
The more boats we get with our system on board, the further that puts us ahead, because each new boat with our system is collecting data, sending data back to us, and allowing us to refine and improve those algorithms.
My background is in engineering as an electrical engineer, aerospace, nuclear, and did my PhD working on underwater drone swarms for ocean mapping. Rio and I, we are people who love taking up challenging projects. And to us, that's fun. To us, it's fun to do something that has never been done before. Given that our passion for the ocean is so aligned, when we realized that there is this opportunity, we couldn't think of anyone better that could join forces.
Where we go next is really demonstrating this end-to-end vision. So to date, we've demonstrated the core pieces of the autonomy. Next, we need to prove out that we can put this in a package where we can achieve the cost savings we're stating. This is really about hitting that price point, that cost where your average person can use this solution. It's not something for just the elite.
Today, we might have some difficulty in imagining that we would take the waterways for transit. But let's say I tell you that I'll wave a magic wand, you just pay $10 and I can shuttle you from point A to point B with no traffic, much faster than all your other options. Would you take it? Yes. And maybe that magic wand, that answer, is the water taxi.
Solving our transportation and congestion issues is an incredibly large opportunity, and it's an incredibly important opportunity.
What we are trying to do is to perfect the technology for one vessel, one kind of application, and then just scale. And to us, that's the winning strategy.
Being on the water is a very special feeling. When I go out on my boat, within 15 minutes, 20 minutes, I can be basically in solitude. I think that's an amazing feeling, and imagine your morning commute. Instead of sitting on a crowded bridge with horns honking, you are gliding over the water on your way to work every day, and I think that would be an incredible experience for people.